So far, the only method of factoring we've talked about is this idea of GCF, greatest common factor, or what all the pieces have in common in my polynomial. So if I look at this example here and look at the three terms and try to use GCF to pull everything out, I can't pull out any numbers, I can't pull out any x's because they don't share anything in common, and I'm kind of stuck. So I have to go back and I have to use a different method. In this case, my other method is going to be called a equals 1. And the reason it's called a equals 1 is because I label the coefficients on my terms as a, b, and c. So here if we look with x squared, there's a 1. I'm allowed to use a equals 1 if I have a quadratic trinomial with a coefficient of 1, which is what I have here. Quadratic meaning squared, trinomial being 3 pieces, and then again here's my a value of 1. So I'm set up to use this method. When I use factoring with a equals 1, I am undoing distribution, but specifically I'm going to undo FOIL, which is good to keep in the back of my head as I go through this. So I'm now undoing FOIL. And the way that I do that is by remembering these catchphrases. I'm looking for two numbers, and these two numbers have to multiply to c and add to b. So in this case, I'm trying to multiply to c, which is 12, and add to 7, which is b. So I look through and I consider the multiplication first. Any sets of numbers that multiply to 12, something like 3 and 4, or 6 and 2, or 12 and 1. Don't forget about that pair. So I look at these sets of numbers that multiply to 12, and I think, can I add 12 and 1 and get 7? No. 6 and 2? No. 3 and 4? Yes. That's my set of numbers. They're the two numbers that multiply to c and add to b. So when I go to write my answer, I remember that foiling involved a binomial times a binomial. So when I undo it, I'm going to go back to a binomial times a binomial. And when I FOILed, first times first gave me the first term, so I have to put an x and an x in the first place. That's always going to be true with a equals 1. And then I take this positive 3 and positive 4, and I put them in to the last places in each binomial. So this ends up being my final answer right here, x plus 3 times x plus 4. And if I wanted to get back up here to my original, I could just FOIL, and I would get x squared plus 7x plus 12. So that's how I go about doing this process of factoring when a equals 1. So let's look at a second example, because it can get a little bit trickier if I have negative signs. So I label my parts. Again, my a value is 1, b is 9, c is negative 36. I want two numbers that multiply to negative 36 and add to 9. So before I think about the negative, I just want to think about 36 and start making a list. Things that give me 36 are 36 and 1, 6 and 6, 18 and 2, maybe 12 and 3, 9 and 4. There's a whole lot of things that give me 36. The hardest part to these problems is thinking through all these different possibilities. Now I know it's a negative 36, but I want to think, is there any way I can put these pairs of numbers together to get this b value, this 9, using either addition or subtraction, because now I have negatives that I can mess around with. So first I consider 9 and 4. There's no way to add and subtract them in order to get a 9. I think about 12 and 3. I can't add them, but I could subtract them, so that might be my pair. 18 and 2, there's no way to put them together and get a 9 using addition or subtraction. Same thing with 6 and 6. Same thing with 36 and 1. So now 12 and 3 are my two numbers, but I have to figure out how am I going to get a negative 36 and a positive 9. I know if they multiply to a negative, one of them has to be negative. And since they add up to a positive 9, I'm going to make the smaller one negative. When I sit back and look at it, I think 12 times negative 3 does equal negative 36. I'm good there. And 12 plus negative 3 does equal 9. So I'm good there. So this is the pair of numbers that I want. Once I've found that pair of numbers, it's as simple as writing out my two sets of parentheses for my binomials, putting my variable in the first spot, and then putting a plus 12 and a minus 3. Now, it doesn't matter if I put the minus 3 in the first binomial and the plus 12 in the second. The order doesn't matter. When I FOIL it out, I would still get my x squared plus 9x minus 36. So that's my factored answer right there. One last example, very quickly. I start out again with a trinomial that's quadratic. A is 1, B is negative 11, C is positive 10. So two numbers that multiply to positive 10 add up to negative 11. List out all the things that give me 10. I know it's 5 times 2. And then I might stop and think, wait, there is another one, 10 and 1. But there's nothing else. So I think, is there any way to add and subtract 5 and 2 in order to get 11? No. Is there any way I could add and subtract 10 and 1 to get an 11? Yes. So I have to think a little bit more about this. If they multiply to a positive but add to a negative, well, anything that multiplies to a positive means it has the same sign. So they're either both positive or both negative. In this case, I'm going to think that they're both negative. So I'm going to try it out quick. Negative 10 times negative 1 is positive 10. And negative 10 plus negative 1 is negative 11. So I get what I want in terms of my pair of numbers. So I just write out my final answer, put the x, and minus 10, minus 1. And again, if I wanted to go ahead and solve that, FOIL it out, distribute, combine like terms, whatever you want to call it, I would get x squared minus 11x plus 10. So the key thing is finding two numbers that multiply to c, and at the same time, those two numbers add to b.